Yeah, so I'll just repeat that again. So when I take the green sine x cosine x and the cosine sign, it's like saying you have like terms. Okay? So I basically say if I have, this is what I just said to Charlie, a times b plus a times b, right? Would you say 2ab? Same exact concept. Okay, on the next slide, it actually lists for you what we consider the 5 double angle identities. The sine we just proved. In a minute, we're going to prove one of the cosines. In your homework tonight, you're going to prove 2 of the cosines. The tangent we won't prove. It's pretty messy, but we will use it. For now, we're going to prove one we already have proved. I want you to do me a favor. Change these 4s to 2s in a couple places. Change them here, and change them here. And we're going to prove this identity the exact same way that we just proved the sine of the sum, or the sine of a double angle identity. If I want to talk about the cosine of a double angle, how did we already say we could split this up into something we know? Turn it into cosine of x plus x. But literally from yesterday's quiz, what does that become? Cosine of times the cosine of x. Yeah. Well, it would be y, right? That's right. It's just that in this case they're the same. Then what operation is here? Minus the sine of x times the sine of x. This becomes cosine squared x minus sine squared x. Wow. Now you have the sine of a double angle and the cosine of a double angle. You with me? Okay. So on the next slide, we're going to start to prove these. And what I want you to be thinking about is that 4-point scale. If I am graded on a holistic 4 points, how many would I earn? Would I earn 1 point because all I can do is make a quick substitution? Would I earn 2 points because I can at least take a few steps even if I can't really prove it? Can I earn 3 by getting really, really, really close, or would I be earning all 4? Now, we're going to talk through a couple of these, and then on the other ones you're going to try them, yeah.
So what was the last step on the previous?
Just cosine squared minus sine squared. Right here, Ben. Okay. Okay. So when you look at letter A, what do you see? What do you see? Parentheses, which inherently mean that I could what on that left-hand side? Be careful. What do you mean by distribute? Be careful what you mean by that. Yeah. So for the record, Algebra 101, does that square go to both sine and cosine? It does not. Be really careful. However, what does this sine x plus cosine x squared mean? Times itself, right? Okay. So write out. This is, I'm gonna have a hard time squeezing it in. I'll fix that. But write that down. Sine x plus cosine x times sine x plus cosine x, and start multiplying it out. Now do me a favor, for the most part, I don't want you working on your own. By tomorrow and Monday, you are going to be working way more independently. But for another day, let's go ahead and be working with somebody else, start comparing your work, and then we're going to go through this together. Go. Quiz took place through the whole period. Yeah. I gave extra credit, but I don't really know that anyone wrote it down. We're not going to worry about it. Did you just send your video? Yeah, we'll do it. I'll get more opportunities later. That's okay. Yeah.
Certain problems they refuse to do on the extra credit.
Yeah. Well, it was just on the homework.
On the homework, because I looked on school junior.
Well, I thought I hit submit and then it didn't go through. So I don't know if I just didn't hit it, which is possible. But either way, I'll give other opportunities. Okay, distribute this. What do I get? When I go ahead and FOIL this out, multiply it out, what do I get, Charlie?
Sine squared x plus 2 sine x cosine x plus cosine squared.
Yeah, so this is sine squared. Sine cosine plus sine cosine is 2 sine cosine plus cosine squared x. Now, I have to, in terms of points, this would basically almost get you 2 points. But you've got to take substantial steps now to show that you actually know how to systematically prove that right-hand side. If you see things, tell me what you see. Rachel.
On the other side, you can do 2 sine x times cosine x.
Yeah, you can. I think which is totally fine. I'm going to hold off on that just because I don't think you have to do that on this one. Yeah.
You can add the sine squared of x and the cosine squared of x, and that's 1.
Yeah, I want to constantly be looking for that identity right there, that sine squared plus cosine squared. I have 1 plus 2 sine x cosine x, and it's okay if you don't see it yet, but moving forward, we definitely want to see it. What is that 2 sine x cosine x? That is the sine of 2x. So my last substitution is the actual step in which I basically reverse the identity. So that now I'm given the expansion in red, and I write the simplification there in black. Okay, yeah.
Can you just change it on the other side so you don't have to change it to sine?
So here's the deal with the proofs. You have to take one side, and you have to go all the way until it literally hits the starting point of the other. So at times, and the next one's probably a good example of this, at times you may need to mess with this to have any idea if you're close.
No, you didn't have to. I just didn't simplify the other side. I changed that to that, so I didn't have to.
You do still have to, though. Let's say you got this other side to be 1 plus 2 sine x cosine x, because it is, right? It doesn't change the fact that that left-hand side, the last line, watch this right here. And will you just raise your hand when you understand this so I know how many times I need to repeat it? I'm not done until the last line on the left equals the first line on the right. Anyone need me to say it again? Give me this requires some sort of body language. The eye contact is nice, but let's try again. For those of you who just flat ignore me. Raise your hand if you understand so I can decide if you need me to repeat.
I understand.
Emily's like on a delay. Okay, are we okay over there? Yes? Okay. All right, so...
Can you explain how you get from the red to the last one?
Yeah, so look at your identity sheet. And that identity sheet, it essentially works backwards. So you see that, see where it says 2 sine x cosine x. Find it, point to it. All the way to the bottom left. Okay, that is the sine of 2x.
Okay.
Okay? Okay, Jizzy.
So you couldn't take the right side and make it 1 plus 2 sine x cosine x, and then just show that wouldn't.
That would not suffice. That would get you 3 out of 4 points.
Okay.
Okay? The idea is that when we're showing a proof, we're actually showing a logical step to get from one point to the other. So when you go through these steps, I don't mind the fact that, in the next one, Jesse, we're going to probably need to mess with that left-hand side in order to show that it actually is the right-hand side. But even in letter B, it won't be done until one side equals the beginning of the other. Okay? On letter B, I just want you to have a conversation with whoever you're working with. Where do you start this? How would you make sure you got 1 out of 4 points? Go.
Wait, how do you decide which side to put again?
Doesn't really matter.
Oh, yeah. Okay.
1 minus
So what's this supposed to be a cube?
You could do
What's the difference between 2 cosine plus sine 2?
Why are the twos in different places?
Oh, the 2 in front is just x and x.
Yeah, because those do make a difference.
Yeah.
One is saying there are 2 cosines,
Oh,
you're
yeah,
definitely
what's-
cosine, and one is saying
So it's cosine plus cosine plus sine of x is x.
yeah, you can think of it like that.
How do you know what side to start on?
Here's the trick. It does not matter. But you have to start. That's like what I was saying about the swiping, right? Like you just get used to a screen telling you something.
I'm gonna do
No.
this very
Can't get like it right. I'm gonna teach you what to do.
Oh, it's that.
You want to come off, Sarah? Because I hear you. It's not lost.
Because this is plus, this is one.
This is cosine. Yeah, that wouldn't be so bad.
And then I just expand that.
Yeah.
And then you add the cosine cosine.
Sure.
Oh, wait.
Here. This is for your growing class. Wait. If you just read it, well,
You're just have only one and you can pick it.
well, but you literally are the only ones. And I wouldn't consider yourself progressive.
Oh.
I'm going with the odd.
I don't feel bad. I mean, it's not about students. It's not about students. It's about your full.
No, I'm doing that. Just play.
Your phone.
You're going straight to.
Okay, you ready? Tell me anything you wrote down. Think, I gotta at least earn a point. What am I gonna write down, Emma?
I turned the sine of 2 theta into 2 cosine. Wait, no, into 2 sine of theta times cosine of theta.
Yes. Okay. So what Emma's saying is, look, I at least applied the identity. She took sine of 2 theta and made a substitution. For the record, I mean, you can leave this over here. You can do Ellie, I don't know if you heard what Ellie said, but Ellie went ahead and split this into cosine plus 2 sine cosine. That's totally fine too. Honestly, I'm with you. It doesn't really feel like there's too much else I can do there. So typically, what my next thing to do is to go to the other side. Now, here's where I don't inherently think you would know what to do on that other side. Let's start with this basic question. Can you cancel anything? That's a trick question.
No.
No, you cannot cancel addition and subtraction in the denominator. So, the one thing that's legal that we haven't talked a lot about, but now that we're talking about it, it becomes fair game, is to multiply by something equivalent to what? 1. That's a legal step. It's kind of like finding a common denominator in a way. The only difference is I don't need a common denominator. What I need instead is for that denominator to clean up. So, what could I do that's equivalent to 1 that would help with that, Charlie? Why would that be helpful? Careful. What is this? It is going to be what we do. And it's going to be on bottom and on top.
I don't really remember why. I just remember doing it.
Okay. It's basically, you remember that because it's basically the idea of the conjugate, right? What if you have to get rid of 1 plus I in the denominator, what do you multiply by? Yeah, if you got to get rid of 1 plus root 7, what do you multiply by? But does it totally get rid of a number? It just gets rid of the radical. So what does this become? Careful. Multiply that out. 1. Okay, I'm not telling you. This is where you're just staring because I'm a screen, basically, to you. Multiply that out. Go. Multiply that out. It really is. I'm going to start referring to it often as the screen syndrome. Yes, Sarah.
1 minus sine squared.
Yes. Yes. But have you tried multiplying it out? Write it on your
Oh,
paper.
so then you can substitute in cosine squared.
Yeah. Have you multiplied it out? What is it, Nick?
I give up.
Oh, come on, man. What is it back there, Sean? 1 minus sine squared. And we know, because we've been doing this a lot now, what is 1 minus sine squared? Cosine squared. Now, oftentimes, you're not going to know, I mean, even as it is, have I talked one thing about the numerator at all?
No.
No, because I sometimes don't know. You have to think in terms, partly for partial credit's sake, but you also have to think in terms of my end result may take on multiple phases until it gets to that. So on top now, I have 2 cosine cubed times 1 plus sine of theta. I got it here, and I got it here. right? Because the numerator, 2 cosine cubed theta, there's a theta in there, times 1 plus sine of theta. I'm going to leave it separate. Now, why would I leave it separate?
See if they cancel, so we can separate
Because
out.
now 2 of those cosines are going to cancel, right? So now, these are gone. How many am I left with, however? One of them. So I'm left with 2 cosine theta times 1 plus sine of theta. Now I am close. I'm 2 lines away. Now what? I have to at least see, you agree I'm at least closer to the left-hand side than I was before?
Yeah.
Okay, so now what? John. Distribute. So I have 2 cosine theta what? Plus 2 cosine sine. Now, to Jesse's point, this is not in here, but to Jesse's point, technically what have I just proven? Yes. Did you hear what Corey said? He said it perfectly. He said, look, I just got this on the right-hand side to equal the blue on the left-hand side. But what was the last part of what he said? It's not all the way. So oftentimes, look right here so you can see this. This line right here came from this. So if I got to this, what is the last line?
Put it back.
Just put it back, right? If this here came from this, then this comes from 2 cosine theta plus sine of 2 theta. Right.
You'd be able to see that it reduces to sine 2 theta either way, so why create more work and potentially get the problem wrong by distributing it out? Not distributing, but expanding it out.
Where?
For the blue line on the left.
Oh.
You already know that 2 sine theta.
No, so yeah, so I get what you're saying. The only reason we did is because when I asked at the beginning, what do you see? What people see is on the left. And what I want you partly to do is to get rid of the fear. Like sometimes the fear is I don't see it right away, and so what do I, be honest, what do I do when I don't see it right away? Literally nothing, right? I just stare at it. So this point is, hey, look, okay, fine, just don't stare at it. You've got to get something down. And if you notice, honestly, until we got to about right there and here, I don't think you can see it in that second line, do you? Now, I don't feel like there's anything about that second line that would be like, oh, okay, I know what's going to happen. So the only reason I'm saying I think it's helpful is because besides everything else, I'm going to get partial credit that way. Right? Okay, other questions? From here to here? This is the identity. It's the same thing as what we did actually in A. Okay? So if you notice at the bottom of the page, you've got top of the next page, you've got C and D. Okay? So this is going to be the last of, what are we in here till? Okay. We're going to spend about almost 10 minutes working through C and D, and then we're going to talk through them together. Okay? So take your time, but here's the deal. You have to write something. So if you are stuck and writing nothing, then get your hand up so that I can help. Deal? Okay, go. Yeah.
How did you, here, like, how did you go from,
Yes.
when you expand this out, does the 3, like, vary?
It does not distribute.
Yeah, it's just
If
like
all-
three.
Yeah.
Wait, the 3 doesn't distribute?
No.
So what do you
Does it?
So, like, it's,
So it's
that's not,
Yeah, well, you did.
Yeah, I did, that's right.
Okay.
It's like 2 lines.
Wait, why can't it be 3 second 3 minus
Isn't
3
it technically
second
the final?
6? Oh, that makes sense.
Yeah, isn't it technically the 6
I need to distribute that
times
everywhere. I was planning to get really stuff.
Yeah, so why isn't this just 3 times?
What side are you saying? Right?
No, what is it?
Yeah, I'm not-
Yeah, the only thing I would say with yours though, because
Be careful, Grant.
this is different.
Yeah.
I
Okay.
circled the-
I was like, I'm looking forward.
Yeah.
So the way you wrote it,
Dude,
was like
these-
3 plus 1. That would be this becomes this. Okay, so most of you are already winding down with C. So honestly, there it is. I just did it in 2 lines. Same. Yeah, it's true, actually. I don't know how, I can't even argue with you.
Seems too easy.
No, it is easy.
X plus X plus X plus X.
Why is that?
Can I do like sine of X, 2X plus sine of 2X, and then do sine of
On D,
X plus X?
there are all sorts of ways to do D.
Can I
Yes.
do like sine of 2X plus sine of 2X? I want not doing it.
You can do sine of 2x plus 2x.
Then can you split that up?
There's no such thing as distributing.
Not six sin X.
Here's the other thing. You can do it different ways. I can't tell. I think factor out. Yeah. You can factor it out though.
I know, but then I did it already. I just don't like that I did it the way I did.
This way.
Yeah.
Why is that second line not like 6 sin x 3x?
Yeah. Doing D.
If I had 3 times 2 times
Guess he's not doing well. Yep.
that's all this is.
Yeah.
I'm terrified. I don't know. Second day in a row.
I can't figure it out. I got 4 sine x times 2
No
times that.
Wait, you worked on the left?
Here's the sine of x plus f. So sine of x plus f. 2 sine times cosine. And then if you just double the rest. How do you think that can double that?
Should I got it?
Would you do 2 sine x? You can factor it out. Yeah, so if all else fails, put it in terms of A's and B's.
Wait, you can factor because I was
Yeah, I
like,
did.
You can B's, A. Cosine x times do A.
I don't want to do it. So Grant's gets jacked off. You know, it's hardcore.
And then you get A.
I have a feeling this is scared. I regret doing this.
Yeah. So here's start messing the right side. Right side.
Yeah, but right side's
Minus 1.
Cosine squared of x. Well, I tried to tackle it.
I tackled it. If you could tackle mine with
Okay, this is not this. Right?
this man, you gotta check out my sick work on
No, I think
Work
it
is
was.
probably really bad.
Okay.
Yeah,
Is it equal to
No.
times squared?
I'm not sure. You're thinking because that's like saying if I put any number there, it pops out. That's not true.
Yeah.
If it were 2,
So what is this?
Yeah.
well, tell me, how do you get the 4x?
Yeah.
Are you sure it's not negative 4x?
Drop the 1 from this side and bring this side back. You can think of it as 2.
Yeah, but if you drop the 1, it's still.
I think it has to be negative 4. Because it's not 2 of these, it's 2 of these.
You see that?
2 of the double angle.
Wait, yeah, what did you do?
I love this. And this is an identity based on that.
Wait, are you gonna go over? Wait, does that equal
Yeah.
1 or something? Because we already factored out that's what we need. So
You're implying that this number is 7, so I just popped 7. That's not how that works. You have to somehow relate 4x to this. You can't just read. However, even though as Sonic said, that way it's scary.
I tackled it, but not up.
Yeah, it must have been
Right.
Wait, no, there's 2 of them.
I thought I had it.
Yes, except when I take the 4 out of it. Yeah, when I take it
Oh,
out of this.
It's 2 times negative 5.
Negative 2 getting.
Okay, so I love this. And yes, I'm
Because
going to crack.
cosine squared
So there are a couple things you can
x
do.
minus 1 is equal
See
to
how-
Here.
Well,
Yeah.
one way is to say,
But then, so cosine in the parentheses, so you can cosine squared x minus 1
left side.
negative sign.
And now I'm
Yes, there you go.
I'm not done, but it's starting to make sense.
You could. I will tell you, you don't need to. You're super close to being done. Yeah.
Trying to make sense. Okay, I feel like this is a really dumb idea.
Oh, because you're distributing.
Right side. Instead of
Yeah,
that,
it's actually-
4 cosine x.
Okay. I mean, I'm pretty proud.
You said that to literally anybody, and then everybody said,
So you would cost the systems everything.
okay, so this is not true. However,
What's not
What is
see,
not
I
true?
was about to say this now. I'm like,
No, it's me.
What's not true?
2 cosine squared x minus 1 is not cosine.
Negative 2. It's negative 2, right?
You're making up an identity.
But if is it true that cosine squared minus 1 is negative sign?
Yeah, cosine squared x. Yes.
Okay, so if there's 2 of that,
You'd have to have 2 of everything. You can't randomly like throw 2 on one and 2 on the other. I agree. I don't know. Maybe
It's unsolvable. I knew it.
The one thing we tried, and then you just said you can't do anything with it.
Is it D&E?
Can it be D?
Okay, I'm gonna talk through a couple things with you. And there are a variety of ways you can approach these.
Cosine 2x.
Oh boy.
I'm gonna show you what a bunch of you started. Raise your hand if you factored on the right-hand side. Okay, so I've been saying this a couple times, and tomorrow or Monday, I still haven't decided which day, we're actually gonna make a legit toolbox list. Have I tried this? Have I tried that? So one of the ones in your list is, have I tried factoring? When I factor that out, I have 2 cosine squared x minus 1. Now, you're not great at this yet, and that's no big deal, but look at the bottom left-hand corner of your identity page. Factory makes
Bottom
zero
left
sense.
hand side.
Yeah, I got, okay, so it's equal
Here,
to
how about
cosine of 2x.
it's equal to, yes. So we haven't proven this one yet, but the truth is that 2 cosine squared x minus 1 is cosine of 2x. Do you see it on your identity sheet? Okay. Now, this is one approach. In the long run, you may be like, I would never have seen that, and that's okay. I'm going to show you another approach. But I'm going to also show you this. 4 can be broken down into 2 times 2. Agreed? Okay. But then look. What is this? That's the sign. I'll move these for a second. Hang on. That's the sign of 2x. So really what I have is 2 sine of 2x, cosine of 2x. If you see that, what's there in black? Will you raise your hand? Okay, now, first period, that's why I created these dumb little circles, but first period had a really hard time with this, but see if you follow this. That is the sine of 2 times the angle. Now, I can tell by your faces you're going to need this too. Okay, so watch. See the dumb little circles?
Yeah.
Okay, so if I had 2 sine dumb circle, cosine dumb circle, wouldn't you say you could work backwards to this? To sine a 2 dumb circle. Listen, we just did this in 2 other proofs. We totally did this exact step in 2 other proofs. If I have 2 sine cosine, don't I have sine of 2 something? Okay. Well, look. Yeah, like we don't want to sure it. We want to like look on your sheet.
Oh, I get it.
It's the undoing of an identity basically. If I have 2 times the sine of something, cosine of something. Do you see what if you at least see it, will you raise your hand? Are you messing with me? Oh, I was like, yes, it is like an identity. Yes, look at the bottom left. Bottom left. Sine of 2 theta equals 2 sine theta. Cosine theta.
Oh, okay.
So I have that. The only thing is, what's under the circle? This. So therefore, what do I really have? The sine of 4x. I think you're messing with me with that whole thing, but
That was so much easier than what I did. I took the left side and completely.
well, we're gonna show the left side too. Say again.
It fell apart and I was so
How do you from one with your
Alright, now.
The one with the what?
the second step
Give me colors.
on the top? It's black and green.
From black to green.
No, put your cursor up. Yeah, that.
From here to here?
Yeah.
Well, hey, don't I have 4 more minutes? 3 minutes? That's plenty of time, so sit still.
What kind of all?
So this right here is sine of 2 theta.
Oh yeah.
That's all. Okay.
I should.
I want to show you something. I'm using all 2 minutes. What I now have is like a minute and a half. Because I'm going to assign you both proofs and triangles. I want you to look at number 4 on your homework worksheet that I gave you yesterday. Now, I'm going to keep you until I'm done. So if you don't stop talking long enough to get this out, you're going to be here after the bell rings.
Just write it down, dog.
So when I look at number 4, I'm given the exact type of information that I was given in worksheet 4 in sum and difference. Where is angle A? Look at number 4.
Quadrant 4.
Where is angle A? Why?
Because between 3 or 2 pi and 2 pi.
Okay, so my angle is down here, and what does it tell you about angle A?
And then the
cosine is
3/5.
3/5. How big is this?
4.
Well, negative 4. What I'm asked to find is no different than I was asked to find before. I was asked to, in this case, I'm asked to find the sine of 2a, correct? Does it say that? Okay, Charlie, if you don't get your stuff back out, I'm going to take longer. So, what I taught you yesterday, and the day before, really the day before, was write down what the identity is. What is the sine of 2a? We've now done it like 18 times.
sine of a plus a.
What is the sine of 2a? No, use the identity. 2 sine a cosine a. Now, what is the sine of a? I heard it, negative 4/5. What's the cosine of A? 3/5. This simplifies to be negative 24, 20. Don't move. Negative 24, 25. Now, I'm going to assign certain problems from that worksheet. Ignore that it says optional. I'm going to say it again.
So is it required?
Yes.
Are you messing with me?
Continue.
These are the problems you're going to do. 5, 6, 8, 13, and on 14 you're only doing
All of
sine of
13,
2a and cosine of 2a. What?
all of 13, like A and B.
That's a big
And A, B, and C for A.
Yeah.
Holy God.
Okay, bye people. Have a good rest of your
I
day.
might die to double.
Are you finishing 4 too?
Oh, we're in the chat.
No.
Oh.
No, because I haven't taught you half angle and
Oh,
double.
right.
That's
Yeah.